Competence in health, safety and welfare risk management issues is a key part of becoming a chartered civil engineer. At your professional review, you'll be required to demonstrate that you understand your personal responsibilities, have a sound knowledge of legislation, have a detailed knowledge of the hazards in your field of work, understand the wider benefits of good safety practice. You can apply risk management techniques. If you're a designer, you can apply the risk hierarchy to your designs. When you're on site, you can deal with people and ensure a safe place of work. And finally, you understand the need to keep your knowledge up to date. So, what's the best way of going about it?
Well, to find out now, we're joined in the studio by Russell Calderwood, who's an ICE and IOSH elected councillor, who was for 15 years one of Her Majesty's Inspectors of Health and Safety. Very warm welcome to you, Russell.
Pleasure.
So here you are, you want to be a chartered civil engineer. So tell me, in broad terms, how can you satisfy the review standard?
That's a wide-ranging question to start with.
Well, indeed, because it seems like such a lengthy list of requirements. Where do you begin?
The three competences we're looking for, which form the basis, are qualifications, knowledge and experience. And that's looking to acquire those over a good number of years before you go for your review with the institution to be able to become a chartered member. And they take some time, obviously university for the qualification, in fact, as regards a master's degree in engineering. And then likewise the knowledge that's acquired through the experience at university, and also what you gain on site. And then experience, a good number of years under fellow engineers, in fact, who are able to guide you through the learning curve.
So you've really got to prove your worth, and actually quite rightly so. I mean, you want to improve standards within the industry, obviously. Yes. What about the training record? What needs to be shown here?
It's looking for the candidate to be able to ensure that he's being structured in what he's developing, his knowledge and experience. And it's looking to require him to record the events and incidents and work-wise that he carries, the various types of experience, whether it's in the design office or out on site, and record it in a structured manner on a date order so that he can offer it to the reviewer to be able to show, look, this is ensuring that you are understanding I have covered all these subjects, you know, up until this time, and continues on as well.
Well, exactly. It's a process of continuous learning, isn't it?
Yes, very much so.
And then to what extent do you have to have a formal certified training course and so many hours sort of undertaken? Or can you do your own thing, provided it's given the stamp of approval? How does that work? No, we're looking for formality here because it ensures that all various aspects of the training that the institution will require. I'm not looking to speak here on behalf of the Institution of Civil Engineers. I'm thinking of all institutions because they each have their own different requirements, like with the electrical engineers or the mechanical engineers. We're looking for the professional chartered engineer who's going to be coming forward to show he has a wide-ranging experience, but obviously with various specialisms, in fact, to ensure that he's understanding that he's able to take on board the professional conducts that will be expected of him in the future. And with regard to your training reports, what do you need to be able to show to satisfy the reviewers?
It's obviously a report in a standard form is what the institution requires. Plus you will have developed a design, plus you will have been involved in sort of like quantities, etc. So it's your own practical experience you're looking to highlight to the reviewers, the people you'll be sitting down in front of, to show that you covered a wide range, you have a good understanding of engineering, and you can present and communicate.
And how many days of health and safety training have you actually got to undertake?
There's a number of like 5 to 10, but it's a varied. If 5 days is the order of 40 hours a week, which is 1 hour, 40 hours, say in total for a year, which could be 1 hour per week, etc. But it's going to be built up with going on specific basic training in health and safety issues on the construction sites, or it may be specialists like plant operation, which would be another background if you're involved in craneage. So these
very much an integral part of the job, isn't it?
Indeed, it comes naturally. Which most people will realise after they've taken on board, but at the start it may seem a bit cumbersome or difficult, etc., but it comes naturally, and looking to highlight here through your programme here that it comes through a structured programme, a formalised structured programme, and that ensures that when you sit down before the examiner, you can have all the ticks in the right box.
Well, we were talking about the need to have a sound and up-to-date knowledge of health and safety legislation. So let's explore that in a bit more detail now.
The Health and Safety at Work Act 1974 is the primary legislation which lays down general principles for the management of health and safety at work. Specific health and safety requirements are laid out as secondary legislation through a series of regulations. There are nearly 200 in total, covering areas such as the control of substances hazardous to health, COSH, the management of health and safety at work, personal protective equipment, working at height, lifting operations, and, of course, construction design and management. It's worth mentioning that before 1984, building regulations came under the 1974 legislation, until a separate Building Act established a scheme of general regulations designed to secure the health, safety and welfare of those using buildings. Accompanying these regs are approved documents showing how the designer can satisfy the regulations.
Russell, can you explain a bit more about the difference between the primary legislation, the 1974 Act
Yes.
that Michael was just referring to, and then the secondary legislation, the regulations?
Right. The Act, the Health and Safety at Work Act, is one of the best pieces of legislation that we've had in this country. And further to that, what I'd like to call the Bible for the engineers in the industry is the Construction Design and Management Regulations. And this is revised quite recently, in fact. And this should be on every engineer's desk.
Well, I say, Russell, it's well thumbed by the look of it.
Indeed, because there's many aspects to it which helps engineers to take forward their duties and responsibilities.
And that you have on your desk and refer to all the time, do you?
Indeed, I do.
OK, so which regulations do you think, if you were an aspiring engineer, what would you say, this is what you've really got to get to grips with? What would be your answer to that?
It's being understanding that there are management duties as well as understanding the technical requirements for carrying out the work safely on site itself. There's two aspects to it. So it's the management and the technical issues. The management in the first part of this book and the technical issues at the back. And I say that as regards the management of the administration duties, responsibilities as regards to oversee a project safely in accordance with the regulations. And the technical aspects are how you manage the site as regards the welfare issues, as regards barriers to trenches.
And then if we come to the building regulations, safety features really prominently in those as well, doesn't it? So presumably an aspiring engineer has also got to familiarise themselves with those.
Yes, not to the same degree as he needs to be understanding of CDM, but we have in Part A, this is the design considerations, this is the loading areas. Part B is fire, and Part P is electrical. So there needs to be familiar with those.
Well, there's a bit of background there. Let's try and tease out now a few practical issues in our first case study.
You've been tasked with designing and supervising the construction of a strip foundation for a house. There are going to be a number of health and safety issues for the designer and the site manager. While on site, it becomes apparent that a stone column for ground improvement will be required. You're tasked with the design and construction of the column foundation.
Well, Russell, would you say that's a fairly straightforward example?
Yes, it's these days in what we call grey areas of ground, which is has fill in it. We need to have in piles and stone columns, in fact. And
Okay. So the obligations as a designer then, with respect to the strip foundation,
Yes.
what are they?
It's looking to ensure, the primary is that it can be excavated in a safe manner, yes, and that it's guarded, and you have a hole, a fall issue, so ensure that it's barriered.
So that's what you're expecting. We move out onto site. What would you recommend the engineer be on the lookout for?
The first thing with a site, in fact, and I have to keep mentioning this, is regards hoarding, fencing off a site, because unfortunately construction sites are attractive to children, and therefore we make sure we secure the site, and then works can be carried out safely within that perimeter area. Particularly as regards, we've got movement of vehicles, excavators, bulldozers, and that type of equipment. And thereby, following on from that, we will have some form of JCB, not to sell a product there, but it's a normal excavator for digging the hole, digging the trench, in fact, and that needs to be safely managed.
Okay, and then once we get there on the site, we discover some unforeseen ground conditions, which means that we've got to have this design of a stone column put into place. So what do we need to be aware of now? What must the designer be watching out for?
Well, with those issues, in fact, you're going to have material delivery. You're going to have manual handling issues, in fact, for the product. It may not only be an excavator involved, there could be a piling rig of some description or a borehole for excavating the earth in which the stone column may well. So there's different health and safety issues arising from that.
And as an engineer, do you find, should the alarm bells immediately be ringing the moment that a design gets changed during the construction of a project? Should the alarm bells start ringing because you think, oh, any changes?
It is, and that's one of the primary requirements is communication, coordination and cooperation, in fact. 3 Cs, which CDM now requires of people. And thereby, if the change is going to be ongoing, they need to be communicated. Not necessarily in writing all the time, but at least you have meetings to ensure that progress is understood to be up to date.
So your 3 Cs there, Russell,
yes.
How do they get implemented in practice? Well, they sounded good, but talk me through it. How does it actually happen?
Right. Well, we have major and minor projects. For a start, anything which goes beyond 30 days is seen as a major project, and you need to have a coordinator, and this is an official title for an engineer, a competent person to ensure that the organisation follows the health and safety requirements of the legislation. And he's tasked with ensuring communication, the drawings, project information flows between the designer, the client, the contractors. He also needs to ensure that it's coordinated, so that he ensures that meetings are held and that people cooperate. And through those 3 Cs, then you will get a job going through safely.
But in reality, I should imagine that there's a last-minute change, you're working up to a deadline as ever, lots of pressures on everyone in the team. I'm sure it's all too easy to let the recording of everything that's happening go by the wayside. In
construction industry, I'd say that they're well versed in dealing with last-minute issues. And this comes from the historic way that UK has developed its professional construction industry. So they are able to deal with that, and they do understand that there will be last-minute drawings. And information technology has been extremely good in communicating these.
But it's important to record all of that, isn't it?
It is still.
Make a record of everything that's done.
Indeed, because part of it needs to be going on file, and the file is then handed to the client at the end of the project for him to be understanding what he's had built.
Great. Well, let's move on now to have a look at our second case study.
You've been given an entire single-storey housing project to design and construct. You're asked to provide an outline of how the works would be taken forward, paying attention in particular to the hazards and how you deal with risks arising.
Well, let's have a look, first of all, then, with the feasibility stage, Russell. What do you think our young engineer should be looking out for in terms of health and safety here?
Again, I'm going to mention again about hoarding and fencing for a site, in fact, okay, because it's the primary requirement for ensuring that it's a safe area in which to work. And the young designer in the feasibility study will be sketching out where the layout will be. And he should be ensuring that he has a good understanding of how he can apply health and safety issues so that he has a proper access to the site, for the layout, so therefore the plant can be brought onto site. If there's public issues as regards other housing estates next door, the engineer is aware of that. So these are the initial considerations, and thereby, is the land, is it contoured? Is it on a slope, in fact? What other issues are the ground condition issues, in fact, actually? Water, runoff, in fact, it becomes an issue, in fact. So he should be understanding of that as regards the health issues there and a safe working area, a dry, safe working area, in fact. So is he going to build the roads first to be able to then develop the housing estate?
So what you're talking about is actually designing out quite a few potential hazards.
Indeed, yes.
Just by getting the hoarding up, you're immediately designing out some hazards.
Indeed.
Are there other hazards you need to be aware of?
They're so numerous.
Oh, right. I tell you, look at the study notes for those, OK?
But, and they're wide-ranging. It's, as I say... It's
like what, though?
Wide-ranging. Like, we have electrical Are there overhead wires? Is there hidden services under the ground that they need to have surveyed and ensured that they're familiar with, in fact? What type of plant is coming to site and who is going to be managing that, in fact, from the designer's viewpoint? Can he look to build off-site? Can he pre-form some of the structures, make them in an industrial complex where they can be made safely and to better quality and then brought to site and erected in one go, in preference to trying to build it on site in a mucky situation where there's slips, trips, fall hazards, in fact.
So as an engineer, Russell, how do you get into this way of thinking and then managing those risks?
Through time. It's something that's built up through having a structured formalised qualification university system that we have in this country, and then having the structured way that engineers, the institutions like to see engineers brought on before they become chartered. It develops in time. It's something that then is acquired and people become at ease with, in fact. And therefore, by part of it is the becoming understanding of the regulations. You know, you're not going to learn them all at once, etc. It's been mentioned about COSH. It's been mentioned about PPE regulations. These gradually come to hand as the engineer progresses in his career structure. And by working on site and actually having a hands-on, then he becomes more familiar with it. His actually ability to communicate, deal with the people who are new to him as regards to subcontractors, as regards the architect, as regards the public, and becoming more familiar at ease, he gains his credibility and competence.
And I suppose we should say, if in the course of doing so he becomes aware of any particular dangers, then he has a duty to highlight those?
It is indeed. And these are it's a responsibility on him, it's a prime responsibility through his professional knowledge and abilities to be able to ensure that anything that may come to his knowledge because of his particular expertise is then conveyed onto either client or public authorities as regards that there's a risk arising from this hazard and there's a statutory duty, and it's a contractual liability, you know, that he needs to be aware of.
And there's a legal responsibility here then, that he has what, a duty of care to the client?
Yes, and there's a legal case that we've got there that people can refer to as regards highlighting where the responsibilities and duties of the engineer, the Hart case.
Can you tell me about that case?
It was a case that a temporary works engineer had designed a perfectly satisfactory approach to ensure that the building was erected safely through the temporary works being in place. But he didn't have any input, or so he thought, to actually what happened on site. And so he went to site, saw that there was issues arising, but unfortunately didn't communicate those on. And because he didn't see that it was part of his responsibility. He was unknowing that really he had the expertise to know it was wrong and should have conveyed that. And unfortunately, an incident came about, and he was found to be somebody who should have really been communicating the problems.
Well, plenty to digest there. Let's just turn now to the professional review itself.
Achievement of health, safety and welfare objectives will have been verified at training review. However, reviewers will still assess how you've approached the subject and what you've continued to learn in the subsequent period. Your reviewers will study your personal development record to verify that general and hazard-specific training has been carried out. Unbalanced or bunched training records will be subject to scrutiny.
Well, let's just pick up on that last point, Russell, because we did mention it right at the very beginning, but clearly continual learning is very important, isn't it?
Very much so. It has to be progressive, and your responsibilities and duties gradually grow as you become more understanding of the time that you spend in the industry. So, yes, very important.
So it sounds like you can't cram at the last minute of the exam.
It's not unknown, but it won't help on the day because there will be so much that the reviewers will go into asking your background history in the subject.
And then what happens after the professional review? I mean, presumably we can't go, that's all done, I don't need to bother anymore.
No, we never stop. I never stop. I'm always continually referring to CDM myself because there's always a new paragraph, there's always a new page, there's always a new approach. There's new technical, scientific developments that one has to take on board. You never stop or continue in professional development.
Well, indeed, there are professional bodies, of course, who are providing this continuous training, aren't they?
They do indeed, and they do a very worthwhile act in this country, because we are fortunate. The HSE, through its 170-year history, along with working with the Institution of Civil Engineers and with the Institution of Occupational Safety of Health, they're the three premier organisations, not only in this country but worldwide, are helping to provide the foundation and thereby the expertise through their own trainers to be able to offer to the engineers per se across our industry of 1 million to 2 million workers background and updates on a continual basis.
And presumably as well, we can make use of the internet these days, can't we?
We do indeed.
And there's plenty of information available on the various websites.
It is. It's readily available, in fact. Google has much to say for itself in looking to offer that insight, which engineers, when they throw in the word excavator, as regards, well, what's the latest type of equipment for carrying out this work these days?
And it's all there at your fingertips.
It is.
Russell, thank you so much. I'm afraid that's all we've got time for, though, today. So many thanks to Russell for joining us and some fascinating insights there. Don't forget, as always, there's plenty more in the study notes, so do dip into those. But for now, from all of us here in the studio, goodbye.